Okay, so we do a test on a 6L6. Got the 6L6 there. Phillips 6L6 from around 1985. Okay, we check that we've got the selectors right. You've got to set it to 026 540 310. 026 540 310. We got filament voltage 6, negative grid volts 18, anode 350, screen 250. Six, about 18, multipliers set to 10 times, that's 18. Plate 350, screen 250, anode 1. Okay, so we're all set to go. Set 0. We check the valve. Cold. Heat is good. Cathode, no short. Grid, screen, anode 1. Only one anode, so no shorts. Take that back to there. We check the voltage is good. And we turn the valve on and wait for it to heat up. While we're doing that, we'll look at what we expect to find. We expect, under these conditions, we expect milliamp current draw 54, and milliamps per volt 5.2. I'll just set that up initially to 5.2. That's about right. 5.2. And we're looking at, on the 100 milliamp scale, we're looking at about, we're looking for this, about 54. Okay. So we continue with our tests while the valve is hot. So that's good. Cathode heater insulation is good, so we can do the test. I don't think the valve is hot enough, but we'll try it. Okay, so that swung to, we were expecting 54, and we got about 66 milliamps current draw. So that's still a strong valve. Okay, just making sure it's settled down. And I suppose we can go and test for the transconductance. Right. So we back off the meter to 0. Right. About there. Let's see what now we're expecting 5.2, so we might have to increase the scale. 25, 10, which should be, we should be right there. Press the, whoops, that's drifted a bit. Oh, very touchy out there. So we check for the transconductance. We're expecting 5.2. We're getting 5.4. Let's move the bit. We'll just reset that. The valve still hasn't settled down. 5.2. Okay, so that's good. So we can now do a quality test, which is going to tell us what we already know. But take that down to 0. There. Now let's see what we get. Should go well into the green. We're looking at the red and green scale. Okay, so that's good. That's good. Okay, so we can take that back, set that back to 100, get the backing off fully clockwise, and we're back to reading the current draw again between 66 and 68 milliamps. So being able to find the current draw, it's good if you want to match the power valves, right? So that they draw similar current when they're in the amp, especially if you have a quad. If you have similar current draw between the valves, it reduces the hum in the amp considerably. Whereas if the valves are unmatched, you'll get a bit more hum. So that's how you test a 6L6. So that's all good. Now we can test for a noisy valve by, now that the valve is hot, we go back to here and the meter's good. Yeah, all good. Turn the valve off. And we're done testing a 6L6. Okay. I'll test a rectifier valve next. So we'll do that next time. Okay. Well, carrying on, we'll do a test on the rectifier tube valve. We've got a 5Y3 GT. Old valve. See how this one's going. I've got the selector set 020809. 020809 030. Right, I'll whack the valve in. And what are we expecting? We're expecting to read 60 milliamps or over on this valve. We have nothing else to set. No negative grid volts, no plate volts, no screen volts. So However, we have filament set to 5. So we'll set filament to 5. No effect, no effect, no effect. We've got 2 plates, so plate 1, plate 2. We'll test plate 1 first. And what are we expecting? We're expecting, according to the book, 60 milliamps. So in this case, what we do is we use the inner scale of the meter selector, which is for diodes and rectifiers, right? So we'll set that to 60, which is there, 60. We'll check the valve. Check the filament first. That's good. All good. No shorts. That was anode 1. Test anode 2. Heater. Good. No shorts. No shorts. Okay. We'll set that back to anode 1. And now we can do a hot test. So the valve is currently heating up. So we're checking plate 1. That's one side of the rectifier. No movement there. We'll check the cathode heater insulation. It's good. Okay, now we can go back to cold just while we change out. Check the other side. No problem. No problem. Okay, now to test the plate 1, we need to move the circuit selector to rectifier and see what the result is on the meter. Now for rectifiers, it's just a good or replace test. If the needle falls anywhere in the green scale, the good scale, the rectifier is working. If it falls in the red, well, it's not working so good. Okay, so let's have a look. Yeah. Oh, that one's working good. That side's okay. What are we getting? We're supposed to get 60. So anything over that's good. We're getting 80. That's plate number 1. We'll try plate number 2. Almost the same. Plate number 2. Plate number 1. Pretty much the same. So no problem with this rectifier. Okay, so we can take that back. And we've done testing the rectifier. Take the meter selector back to the 100 scale. And we can switch the machine off. And that's all there is to it. And that's the end of this video. Thank you.